yes. So non-parametric tests are useful in case of small sample sizes or when data do not meet parametric assumptions. The commonly used non-parametric tests of significance are Mann-Whitney U test. It is used when we have two independent samples, or we can use Wilcoxon rank sum test. For paired sample data, we can use Wilcoxon sign rank test or sign test. Whereas for more than two groups, in case of parametric, we use ANOVA. Here we can use Kruskal-Wallis H test, or it is also called as Kruskal-Wallis ANOVA. Again, sometimes we suppose we have some longitudinal data. We measure blood pressure after 3-4 times after giving drugs at suppose 1 hour, at 2 hours, at 3 hours. So in this case, we have the same group we are measuring at different time intervals. So here we can go for Friedman test, or it is also called as Friedman ANOVA. Okay, and when we have different groups, independent groups, in that case we can go for Kruskal-Wallis ANOVA or Kruskal-Wallis H test. The other non-parametric tests of significance are chi-square test for independence and Spearman's rank correlation. In case of parametric, we have Spearman's Karl Pearson correlation coefficient, and in case of non-parametric, we have Spearman's rank correlation. It is based on ranks. Then Mann-Whitney U test is used to compare the differences between two independent groups when the dependent variable is ordinal or continuous, but it is not normally distributed. Here, hypothesis is that the distributions of both groups are equal. Against alternate hypothesis, the distributions they differ. And here we use ranks of all observations and compare the sum of ranks.
So this Mann-Whitney U test is a non-parametric test, right?
It is non-parametric. It is equivalent to
so it is a
t-test.
It is a counterpart of t-test.
T-test, yes.
Yeah.
Independent sample t-test.
So yeah, Dr. Amrita, just remember with what is this normal distribution is there or not? It is not normally distributed, because
Yes,
then we have to select either t-test or then counterpart of it, that is non in parametric. You have Mann-Whitney U test. Okay.
Yes, sir.
Sir, go
Or
ahead.
again, suppose if data is continuous, it is ratio scale data, but we have not selected participant randomly. We have selected purposively. In that case also, we cannot use t-test because random selection is important in case of parametric test. But here, these assumptions do not required. So when data is purposive sample, so we can go for Mann-Whitney U test. Right, sir?
Yes, sir. Yes, yes.
Yeah. Then when two groups, we have two related groups or we have paired data, we can use Wilcoxon sign rank test. It is equivalent to paired sample t-test. So before after type of data, we can compare using Wilcoxon sign rank test. It is based on median test for difference in, it compares in a sample pair sample t-test, it compares average mean of the both groups, whereas this compares median. In sign test, it is again a simplified version of Wilcoxon sign rank t-test. It counts the number of positives and negative differences. Here we suppose we have two columns before and after, then we find the difference. If positive, we put plus. If negative difference, we put minus. So, and we use these number of positive and negative signs to conduct the sign test. And in case of Wilcoxon sign rank test, we use median of first set and median of second column. Then Kruskal-Wallis H test, it is again extension for Wilcoxon sign rank test. Okay. If we have two groups, we can use Wilcoxon sign rank test. If we have more than two groups, we have to go for Kruskal-Wallis H test. It is a non-parametric alternative to one-way ANOVA. it compares medians across more than two independent groups. Wilcoxon compares median across two groups, whereas this compares median across more than two independent groups. Whereas Friedman test, or it is also called as Friedman ANOVA, it is equivalent to repeated measure ANOVA. Repeated measure means the same group we are measuring repeatedly, more than 2 times. Okay. So if it is repeated measurements of same groups, we can go for Friedman test or Friedman ANOVA. And if data is parametric, we can go for repeated measure ANOVA. Okay. Kruskal values is when we have more than two groups, but the assumption of parametric does not hold, we can go for Kruskal values. If assumptions hold, we can go for one-way ANOVA.
Dr. Amrita, generally they ask you this ANOVA or the Kruskal values. Then you have to, the ANOVA is a parametric test and more than two groups.
More than two
When
groups.
you have
Yes,
more
sir.
than two groups in parametric, you will go for ANOVA.
ANOVA.
Okay, when you have more than two groups, but the it is a not normally distributed or you are using non-parametric test, then you go for Kruskal values test. Okay, so generally these two are important. Okay, and this is one of the important concepts as well. If you have more than two groups and you are repeatedly taking the observations, then Friedman test. Is that right, sir?
Yes, sir. Friedman ANOVA.
Yeah. Okay, we'll go ahead, sir.
And in case of ANOVA, it tells just whether there is any difference or not. If any one of the, suppose we have three groups and one group is different from other two groups, so ANOVA test result will be significant. But it doesn't tell us exactly which group is significantly different. So to find that, we have to conduct follow-up test. We call it as post-hoc test. So that compares pairwise. Suppose we have three groups, then we compare first group with second group, first group with third group, and second group with third group, and it will find which group is exactly different from the other groups. So these ANOVAs, it should be followed by post-hoc test. Then again, Spearman's rank correlation, it measures the strength and direction of association between the two ranked variables. Again, it lies between -1 to +1. Spearman is, it depends on ranks, whereas Carl Pearson, which is parametric, it depends on the mean and covariances, mean, covariance, and standard deviation. Okay? That is parametric, and the Spearman is non-parametric test for correlation. Right, sir?
Yes, sir.
So the non-parametric test of significance can be used when data is not normal, data is either ordinal or rank data, sample sizes are small. The advantages are that there are fewer assumptions, and since we are using here ranks and medians, it doesn't affect, it will not be affected by the outliers, because outliers are on the end of the distribution, either lower end or upper end, but we are here using either ranks or medians, so it will not affect the result of non-parametric test. Then limitations are they are less powerful than parametric test of significance, and here results may be hard to interpret as compared to parametric test. Right, sir? Any doubt?